Welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are going to solve about 20 multiple questions in vector algebra. That is basically Math 202. Okay, so our first problem is we want to find the equation of a plane containing raised 3 points. Okay, so if you have a question of this nature, first of all, what you have to do is that find two vectors, right? Find two vectors on the plane. All right, so we are going to consider in here, we're going to consider ij, vector ij, and vector ik. Okay, so we try to find vector ij, which is equal to j minus what? I. Okay, so that is equal to j, which is 4, 3, neg 1, minus 3, 1, neg 1, right? So this minus this is 7, right? So we have 7, 3 minus 1 is 2, minus 1 minus 1 is 0, right? So we have this here. So vector ij is equal to 7, 2, and 0, right? So we have to find another vector, which is the ik, right? So we have k minus what? I. So k, which is 2, 1, and 8, minus I, which is negative 3, 1, negative 1. Okay, so when you do this, 2 minus 3 is 5. 1 minus 1 is 0. 8 minus 1 is 9, right? So our two vectors on the plane are ij, which is equal to 7, 2, and 0, and ik is equal to 5, 0, and 9, right? So once you have these two vectors on the plane, use the normal, find the normal using the cross product, right? So we are going to find the normal using the cross product. So vector ij cross ik, right? And that is equal to, we are going to use the cross product, right? The matrix. So we have I, j, and k. And vector ij is 7, 2, 0. That of ik is 5, 0, 9. Right. So this is what we have. Let's try to find the determinant. So we're going to have 2, 0, 0, 9 minus j into 7, 5, 0, 9 plus k into 7, 5, 2, 0. Right? So we're going to have I into 18 minus j into 7 times 9. That is basically 63, right? So we have 63 plus k into this times this is 0. Then we have 5 times 2, which is 10. So we're going to have minus 10 here, right? So we have 18i minus 63j minus 10k, right? So this is our normal. This is our normal through the cross product, right? So once we have the normal, then the next thing is we can choose any of the points on the plane to find the equation of the plane, right? So we can choose either I, we can choose either J or K to find the equation of the plane. Okay, so we know that the equation of the plane is A is giving us A into x minus x naught plus b into y minus y naught plus c into z minus z naught, right? And here we have our a, we have our b, we have our c, right? Very simple. So in here, we are going to pick any of the points, right? Then we choose, so we are going to choose I, which of course is -3, 1, and -1, right? So we are going to have, here, our A here is, 18, our B here is -63, and our C here is -10 from the normal. Okay, and our X naught from the I is -3, our Y naught is 1, and our Z naught is -1. Okay, so we are going to fix it into the formula to have the equation of a plane. So we are going to have 18 into x minus, our x naught is -3, so it's going to be +3, plus our b, which is -63, so we have -63 into y minus y naught is 1, minus 10. C is -10 into z minus z naught is -1. It's going to be +1. Okay, so when you expand this, you're going to have 18x plus 54 minus 63y plus 63 minus 10z minus 10. And that is equal to 0, right? Okay, so when you simplify this, you're going to have 18x minus 63y minus 10z. When you add 54 plus 63 minus 10, you're going to have plus 107 equals 0. Okay, so that becomes our equation of a plane containing the points I, J, and K. Okay, so if you have 3 points and you are asked to find the equation of a particular plane, first of all, find 2 vectors on the plane. So you can consider ij, you can consider ik, you can consider jk, right? Don't forget that you are dealing with vectors, so order is very important. So that is why I chose ij, I chose ik, right? So if you're also considering, you can also consider jk. First of all, you can consider I, K, and jk. You can also consider that. Then you can also consider mine as well. So once you have these 2 vectors, use the 2 vectors to find the normal of what? The plane, using the cross product. So once you have that, the result you obtain from the cross product becomes your coefficient, which is the A, B, and C. Okay, so the next thing is to choose any of the points to represent your S naught, Y naught, and Z naught. So in doing that, once you have your correct plane, right, your correct normal, the next thing is any point you choose here will give you the same plane. Okay, so that is how we go through this kind of problem. Okay, so now let's move on to question number 2. So let's move on to question number 2. Okay, so with question number 2, it said a railway line passes through the point A of coordinate 251 and parallel to K and another railway line passes through the point T of coordinate 4, 5, 1 and P of -4, 5, and 1. Okay, so the first question is, we want to find the point of intersection of these two railway lines. Okay, so first of all, we know that surface we have been given line 1. Okay, so we have been given line 1, okay, railway line, okay, which is line 1. Okay, so we have been given line 1 that is passes through point A. It passes through point A of coordinates 2, 5, and 1. Okay, and is parallel to vector K. Okay, so once it is parallel to vector K, we don't even know the vector, the coordinate for that vector, right? So what we are going to say is that we move to the line 2. Okay, in here we have this coordinate and this coordinate. So with line 2, we have that passes through T of coordinates 4, 5, and 1, and P of coordinates -4, 5, and 1. Okay, so first of all, what we have to do is that we have to use the line 2 to find the direction vector. Okay, so we say that line 2, of which we have coordinates T of coordinates 4, 5, and 1, and P of coordinates -4, 5, and 1. What we want to do is we want to use this coordinate to find the direction vector, because that is what is known here. In line 1, we just know a point and it's parallel to K, of which we don't know the coordinate of K. So we are going to use the points of T and that of K, P, to find the direction vector. So we say that TP, vector TP equals P minus T, right? And that is equal to -4, 5, 1 minus 4, 5, 1, right? So this is going to give us -4 minus 4 is going to give us -8, right? Then 5 minus 4. 5 minus 5 becomes 0. 1 minus 1 becomes 0 as well. So this is our direction vector, which is TP to be -8, 0, and 0. Okay, so once we have the direction vector, what are we going to do? So we are saying that this is the direction vector for railway line 2, right? So we can say that line 2 is horizontal along the x-axis with y equals 5 and z equals 1. So we can say that line 2 is horizontal along the x-axis with y equals 5 and z equals 1, right? So the reason why we are saying that is that you can see that y here is 5, z here is 1. Y here is 5, z here is 1. So it means that it is constant. right? So once it is constant, then we can say that line 2 is horizontal along the x-axis with y equals 5 and z equals 5 as well. So now we have this information. The next thing we have to do is we have to get the parametric equation of line 2 because we have the direction vector. We have to multiply the direction vector by a scalar, right? So we multiply direction vector by a scalar plus the points t, right? So the parametric equation of line 2 is going to be point t, or the initial vector t, plus a scalar times the direction vector, right? Which is the tp, right? So we're going to have 4, 5, 1 plus t into -8, 0, 0, right? So we can say that the parametric equation for line 2 is going to be 4 plus -8t. So we're going to have 4 minus 8t, then 5 plus 0 is 5. So we're going to have 5 here. 1 plus 0 is what? 1. Okay, so we can see clearly that the parametric equation for line 2 is 4 minus 8t, 5, and 1, right? So come in. Okay, we can move here. Okay, so we say that R2, that is line 2, right, of t is equal to 4 minus 8t, 5, and 1. Okay, so once we have this, then we can say that the vector k, the vector k is not known, right? The vector k is not known, but we can find the intersection from the common point. Okay, from line 2, we can say that the first coordinate is what? 4 minus 8t. The second coordinate, which is the y, is 5. The third coordinate, which is the z, is also 1. So we can find when this equation equals the point A. So if this equation equals the point A, then we can know the value of t, right? So let's say that if this equation equals A, then we're going to have 4 minus 8t, 5, and 1 equals 2, 5, and 1, right? So when we do that, we're going to have 4 minus 8c equals 2, right? So we can say that minus 8t equals 2 minus 4. And this implies that we have this to be minus 2. So we can say that our t is equal to 2 over 8. And this is equal to 1 over what? 4, right? So we have our t to be what? 1 on 4. So we can substitute that here to have the right evaluated point for the x, right? So when we go here, we can say that R2 of t is equal to 4 minus 8 into 1 on 4, comma, 5, 1, here. Okay, so this, we're going to have 4 minus 8 on 4, comma 5, comma 1, right? So we have 4 minus 2, then 5, 1, right? So this becomes 2, right? So we have 2, 5, and 1. Okay, so we are there. We have satisfied the first part of the question. All right. So the question says that we should find the point of intersection of the two railway lines, right? So first of all, since we don't have any coordinates that we can use to find the direction for vector for line 1, we went ahead to line 2 where we had the line passing through 2 points, T and P, right? So we use these 2 points to find the direction vector of line 2. So once we had that direction vector, we can go ahead and find the parametric equation by multiplying a scalar by the direction vector, okay? Plus any of the, plus the initial point, which is the T. Then we have the parametric equation of line 2. So once we have the parametric equation of that line 2, it means that since there is a variable T, which is the scalar, we can equate it to the railway line 2 because we are looking at the intersection. So we equated it to the railway line 2, which is having the point 2, 5, 1. So the first coordinate was 4 minus 8t, so we equated that to 2, and then we find the value of what? T. Substituted back to have the original parametric equation for line 2. So the line 2 has this parametric equation of which we can say that the line, we can say that the A lies on line 2, right? We can say that the A lies on line 2. We can see that the point that we are having here is the same as line 1 as well, right? So we can say that line A lies on line 2, okay? Line A lies on line 2. So that means both lines intersect at 2, 5, and 1. That means both lines intersect at 2, 5, and 1. Okay, so that is the intersection of these two railway lines. Okay, so the next question is, okay, so with question number 3, we want to find the position vector of the points of intersection of the railway lines, right? So with question number 3, we've answered it in question number 2, right? We just have to assign the position to each of the coordinates, right? So we had 2, 5, 1 for the intersection, right? So the position vector becomes 2i plus 5j plus k. Okay, so this is the position vector for the railway lines. Okay, so that is the end of question number 3. Let's move on to question number. So with question number 4, we want to find the volume of the tetrahedron, right? Having adjacent sides OD, OE, and OF, given that the point D has coordinates 0, 3, -1, the point E has coordinates 3, -4, -1, and that of F is 0, 3, and 1. Okay, so we want to find the volume of this tetrahedron. Okay, so basically we know that if we have the vertices of which is OD, so if we have the vertices OD, OE, and OF, then, and they are having common what? Vertex, which is O. Then we can say that the volume of the tetrahedron is giving us, then the volume of the tetrahedron is equal to 1/6 times the magnitude of OD dot OE cross OF. Okay, so this is what we need to be able to do this particular question, right? So we just have to follow this procedure and we are good to go. This is the formula for finding tetrahedron, a volume of a tetrahedron. You know, tetra is 6, right? So we just, the result we are going to obtain, we divide it by what? 6. So first of all, we have to use the cross product to find OE cross OF. So we have to use the cross product to find that. So OE cross OF will be equal to IJK, right? And we have OE here to be 3, neg 4, neg 1, and OF to be 0, 3, and 1, right? So we're going to have that to be I into neg 4, 3, neg 1, 1. Then we have 3, 0, neg 1, 1, plus k into 3, 0, neg 4, 3, right? So we have the I component to be negative 4 plus 3 minus j into 3 minus 0 plus k into 9 minus 0, right? So we're going to have, this will be minus 1. So we're going to have minus I. Then this is going to be minus 3j. And this is going to be plus 9k. So we have plus 9k. Okay, so this is the cross product of OE cross OF. So once we have this result, the next thing is we have to multiply this by OD, right? So we're going to have OD dot OE cross OF, right? So we're going to have OD, which is, this is basically equal to, okay, so we're going to have 0, 3, neg 1, 0, 3, neg 1, dot, this is equal to neg 1, neg 3, and 9, right? So we're going to have neg 1, neg 3, and 9, right? So in here, this time, this becomes 0 plus 3 times negative 3 becomes negative 9. Negative 1 times 9 becomes negative 9. So we have negative 18, right? So this is the value we obtain. So this has to be absolute, right? So we have, it has to be absolute, right? So because that is how the formula is. So the volume of the tetrahedron, volume of the tetrahedron will be equal to 1/6 absolute of the result we obtained. So we're going to have, this is absolute, right? So, you know, absolute is restricted to the positive side, right? So we're going to have 18 divided by 6, and that is equal to what? 3, right? So we can see that hence the volume is equal to what? 3 cubic units. 3 cubic units. Okay, so this is the volume of the tetrahedron of having the adjacent sides OD, OE, and OF, given that the point D is 0, 3, neg 1, that of E is 3, neg 4, neg 1, and F is 0, 3, and 1. Okay, so we have the volume to be 3 cubic units. That is the process we go through to find the volume of a tetrahedron. So basically it's 1 over 6. You know, tetra is 6, right? So the result should be divided by 6. So OD dot OE cross OF divided by 6. That is absolute of that, because if you don't do that, you're going to have negative. Okay, so that is question number 4. So interesting. Let's move on to question number. Okay, so with question number 5, we want to determine the point of intersection of the line 2i plus j plus 3k and the plane 1 minus t minus s or I plus 4tj minus 3s k. So this question, first of all, if the line is just the line, if the line is just the point 2, 3, 2, 1, 3, if the line is just this, if the line is just 2, 1, 3, of which we have here, then we can't proceed with the question, right? Then it does not intersect, then it does not intersect the plane. Then it does not intersect the plane. Okay? It does not intersect the plane. And so if it's a line through that point, we need its direction vector to be able to proceed with this question. If it's a line through that point, then we need its direction vector to proceed with this question. Okay, so if the line is just this point, right, 2, 1, 3, then it does not intersect the plane, period. So this on the options, it's none of the above, none, right? So if you have a question of this form and you're asked to determine the point of intersection of a line, just a line in the plane, then you need the direction vector to be able to proceed. Because if you don't have the direction vector, let's say you don't have any point, like something like this and this, to find the direction vector, then you can proceed. This question is of the same form in question number 2, right? This is having the same nature as question number 2. But here we don't have any point or the direction vector to be able to proceed. Therefore, this question does not intersect the plane. Okay, so let's move on to question number 4. Okay, so with question number 6, if a line passes through a point C and is parallel to a vector B, what is the equation of the line given that C is having this coordinate and B is also having this coordinate? Okay, so this question is very direct. Earlier on, the question says that C is a line that passes through, if a line passes through the point, a point C, and is parallel to a vector B. So B here is a vector and C is a line, right? So, or a point, right? So we can say that R of t is equal to vector C plus a scalar times a scalar which we are using lambda times the vector B, right? So we can easily get this. So we're going to have C, which is 3, 4, neg 2 plus lambda into neg 1, neg 2, neg 1, right? So we're going to have this to be 3, 4, neg 2 plus negative lambda, negative 2 lambda, and negative lambda, right? So we're going to combine this, and then we have 3 minus lambda, 4 minus 2 lambda, and then we have minus 2 minus lambda. Okay, so this is the equation, right? This is the equation. So recall that a parametric equation can be, this is the x component, this is the y component, and this is the z component, right? So we can say that x is equal to 3 minus lambda. So if we want to make lambda the subject here, we see that x minus 3 is equal to minus lambda, right? So we have lambda to be equal to 3 minus lambda. 3 minus x, right? 3 minus x. So 3 minus x. Okay. So we have lambda to be that. Okay. The next thing is we equate the second component to y. So we have y equals 4 minus 2 lambda, right? So making lambda the subject in this equation, we are going to have 2 lambda equals 4 minus y, right? So lambda will be equal to 4 minus y over 2, right? So we have this here. Then the last part, which is z equals minus 2 minus lambda, right? So making lambda the subject, we're going to have lambda equals minus 2 minus z, right? So once we have lambda equals this, lambda equals this, lambda equals that, then we can equate the three, right? So this equals that, this equals that, right? So we're going to have 3 minus x equals 4 minus y over 2 equals minus 2 minus what? Z, right? This is over 1, this is over 1, right? So basically we can cross multiply with the 2 to avoid this fraction. So when we do that, we're going to have 6 minus 2x equals 4 minus y equals minus 4 minus 2z. Okay, so basically that is the solution for this particular problem. Okay, this is the solution to this particular problem. So note, the question says that a line passes through a point C, and that point is parallel to a vector B, and we are asked to find the equation of the line given this the coordinate of these two vectors, right? So since B is a vector, then that will be the direction vector. So you multiply that with a scalar plus this line, right? Then you have your parametric equation. But don't forget that you can also express parametric equation in a symmetric form. So we equated the first component to x and made lambda the subject. We equated the second component to y, make lambda the subject, the third component to y, z, and make lambda the subject. So since all of them are having lambda equals something, lambda equals something, lambda equals something, then we can equate the three and find and put the results in a symmetric form. So this is the end of the problem, number 6. Okay. Let's move on to question number. So with question number 7, we want to find the unit vector normal to the vectors a plus b and b minus c. If a is given as this, b is given as this, and c is given as that. Okay. So once you have this kind of question, the first thing you have to think of, you just find a plus b, b minus c. So we can represent A plus B as U, vector U. So that should be equal to A plus B. And that of V, vector V should be equal to what? B minus what? C. So we find that, so vector B, A plus B is denoted as what? U. So that will be equal to A plus B is going to be I plus J minus K plus I plus 2J plus 2K, right? And that is going to be I plus I is 2I, J plus 2J becomes 3J, minus J plus 2K, minus K plus 2K becomes plus K. So this is what we have for U, vector U. Okay, so we have to go ahead and find vector V, and that will be equal to the B minus C, right? So we're going to have I plus 2J plus 2K minus C, which is minus I plus 2J minus K, right? So I minus minus I becomes 2I. 2J minus 2J becomes 0. So that component is off. So we have plus 0J. Then 2K minus K. 2K minus minus K becomes plus 3K. So we have plus 3K. Okay, so vector V, which is equal to B minus C, is equal to 2I plus 3K. So we have that here. Okay, so now we have vector U, which is equal to A plus B, and vector V, which is equal to A, B minus C. Then we can find the unit vector normal to the vectors, those vectors. Okay, so what are we going to use? We are going to use the cross product to find the cross product of U and V. So vector V, vector U cross vector V. Don't forget that it's a vector, so it has to follow order. Okay, so we have I, J, K, and vector U is 2I. So we're gonna have 2 here, 3 here, and 1. And that of V is 2, 0, 3. Right? So we're going to have I into 3, 0, 1, 3, minus J into 2, 2, 1, 3, plus K into 2, 2, 3, 0. Right? So we have I into 9 minus 0 minus J into 6 minus 2 plus K into 0 minus 6. Right? So we have I to be 9I. Then this will give us 4. So we're going to have minus 4J. Then this will give us minus 6. So minus 6K. Okay, so this is what we have. So what do we do with this? We find the magnitude of this, then we use it to divide this. That will be the unit vector normal to the vectors. Okay, so unit vector normal to the vectors, you have to find the magnitude of this. So the magnitude of vector U cross vector V will be equal to square root of 9 squared plus negative 4 squared plus negative 6 squared, right? So we're going to have, magnitude of U cross V will be equal to square root of 9 squared is 81, 4 squared is 16, and 6 squared is 36. Right. So when we sum everything, we are going to have square root of 133. So 81 plus 16 plus 36 is 133, square root of 133. So that is what we have for the magnitude, and we have position vector of u cross v to be 9i minus 4j minus 6k. So the unit vector normal to the vectors a plus b and b minus c is equal to 9i minus 4j minus 6k all over square root of 133. So that is equal to 9 over square root of 133i minus 4j over square root of 133 minus 6 over square root of 133k. So this is the unit vector normal to the vectors a plus b and b minus c given these position vectors. Okay, so that is the end of question number 7. Okay, so let's move on to question. Okay, so with question number 8, we want to find the value of x if a is equal to 4i plus 11j plus sk and b is equal to 7i plus 2j plus 6k and c is equal to I plus 5j plus 4k. These position vectors are coplanar, right? And you know what coplanar is. Everything you do should be equal to 0. So this means that a dot b cross c is equal to 0, right? So once you know this, the rest is computation, then you are through, right? So you can decide to find b cross c first, then you dot it with a, or you use the determinant straight away, right? So this, because it is 3, we can decide to use the determinant straight away and we are good to go. So we can have this to be equal to our a, which is 4, 11, and x. Our b is 7, 2, and 6. And c is 1, 5, 4. Okay, this is supposed to be equal to 0, right? So this, when you do it, you're going to have 4 into 2 and 5, 6, 4, minus 11 into 7, 1, 6, 4, plus x into 7, 1, 2, 5. This is equal to 0. So this we're going to have 4 into 4 times 2 is 8, 5, 6, 5, 6, 30, right? So we have minus 30 minus 11 into 7, 4, 28, right? So we have 28 minus 6 plus x into 5, 7, 35 minus 2 is equal to 0, right? So we're going to have 4 into 8 minus 30 is minus 22, minus 11 into 28 minus 6 is 22. 22 plus x into 35 minus 2 is 33, and that's equal to 0. Okay, so this year we are going to have, when we sum everything, we are going to have this plus this. We're going to have minus 330 plus 33x equals 0. So we have 33x is equal to 330, right? So this means that our x will be equal to 330 over 33, and that's equal to 10. So that's the value of x is 10. The value of x obtained here is 10. All right, so if you have 3 position vectors, okay, and they are coplanar, then it means that if you find a determinant, or if you find a dot b cross c, the result should be equal to 0. So once you know this, The rest is computations and you are good to go. So let's move on to question number 9. I hope you are enjoying the lesson, right? Okay, so we move to question number 9. Question number 9, we want to evaluate this A cross B dot A cross C. Okay, so we have position vector A, position vector B, and that of C. And we want to evaluate A cross B dot A cross C. So we need to first find A cross B, which will be equal to I, J, and K, right? So we have 2, 3, neg 1, 1, 2, neg 4, right? So this we are going to have I into 3, 2, neg 1, neg 4, minus J into 2, 1, neg 1, neg 4, plus K into 2, 1, 3, 2, right? So we can say that I into neg 4 times 3 is negative 12 plus 2 minus J into neg 8 plus 1 plus K into 4 minus 3, right? So we're going to have A cross B to be equal to minus 12 plus 2 is basically minus 10. So we have minus 10 I. Then minus 8 plus 1 is minus 7. So we have negative is going to be positive. So we have plus 7J. Then 4 minus 3 is 1. So we have plus K. All right. So this is A cross B. We have to also find A cross C. So A cross C, which is equal to 2 IJK, right? Then we have 2, 3, neg 1, and then C is 1, 1, 1. Right. So we have I into 2, 3, 1, neg 1, and then minus J into 2, 1, neg 1, 1, plus K into 2, 1, 3, 1, right? So we have I into 3 plus 1 minus J into 2 plus 1 plus K into 2 minus 3, right? So we're going to have this to be 4I minus 3J minus J. Okay, so this is what we have for A cross C as well. So what we have to do is we just have to take the dot of A cross B and A cross C. So A cross B dot A cross C will be equal to minus 10 minus 10I plus 7J plus K dot 4I minus 3J minus K, right? So minus 10I times 4I becomes minus 40, right? 7J times minus 3J becomes minus 21 here. Then K times minus 1, K becomes minus 1, right? So this, we are going to have this, and this will give us minus 22 minus 22 minus 40 becomes minus 62. So this is the value obtained for evaluating A cross B dot A cross C, minus 62. Okay, so this is the end of question number 9. Let's move on to question number 10. Okay, so with question number 10, we want to find the angle between the line AB and the plane x minus 2y minus 3z equals 0, given that the point A is equal to 3i plus j plus 2k and B is equal to I plus j plus k. Okay, so this is basically asking us to find the angle between the line AB and the plane x minus 2y minus 3z. So line AB So this, we are going to use this formula cos theta, or let's say cos phi, is equal to line AB minus dot the normal over magnitude of line AB times magnitude of the normal, right? So we know that when you are finding the angle between a line and plane, if the angle obtained is phi is less than 90, then you are going to take it, you are going to have theta equals 90 minus what? Phi. But if phi is greater than 90, then it's going to be what? Phi minus 90. Then you have theta, right? So we are going to do the same analogy here to have the angle between this line AB and the plane. So first of all, let's find line AB. Line AB is equal to B minus what? A. And that is equal to I plus J plus K minus 3I plus J plus 2K, right? So this, we are going to have I minus 3I becomes minus 2I, J minus J becomes 0, right? So 0J, and then K minus 2K becomes minus K, right? So this is the same as minus 2, 0, minus 1. Right, so this representation is what we call angle bracket. You can either use this or use this. Okay, so they are all the same. Okay, so this is called angle bracket and this is called position vector form. All right, so we have the line AB. What do we do next? We have to find the magnitude of line AB. So magnitude of line AB will be equal to square root of minus 2 squared plus 0 squared plus minus 1 squared, right? And that will be equal to 4 plus 0 plus 1, and that is square root of 5. Okay, so we have magnitude of line AB to be what? Square root of 5. Okay, this is the plane, x minus 2y minus 3z equals 0. So represent n, small n, to be the normal. So we get that from the plane. So let's n be the normal, which is I minus 2j minus 3k. Okay, so we also find the magnitude of that, and that will be 1 squared plus minus 2 squared plus minus 3 squared. And that is 1 plus 4 plus 9. Okay, and that is 5 plus 9 is basically square root of 14, right? So we have the magnitude of the normal to be square root of 14, magnitude of the line to be square root of 5. So that times that becomes square root of 70. Okay, so we have that. Once we have that, the next thing we have to do is to do what? Find the dot between line AB and then position vector AB and then position vector N. Okay, so we're going to do that. So position vector AB dot position vector N will be equal to minus 2I minus K dot I minus 2J minus 3K, right? So we're going to have minus 2I times I becomes minus 2. This is 0, so the J component is 0. Then minus K times minus 3K becomes plus 3. So that is equal to minus 2 plus 3 becomes 1. Okay, so we're going to have the angle between the line and the plane to be equal to cos inverse of 1 over square root of 70, right? So we're going to have this, when you calculate this, going to have 83.135 degrees, right? So since this is less than 90, then we say that the actual angle is going to be theta equals 90 minus what? 5. And that is equal to 90 minus 83.135 degrees. And that is equal to 6.865 degrees. Okay, so the angle between the line AB and the plane x minus 2y minus 3z equals 0 is 6.865 degrees. Okay, so that is the process we go through to find the angle between a line and a plane. Okay, so let's move on to question number. Okay, so with question number 11, we want to find the angle between the planes x plus y plus 2z equals 13 and 2x plus 3y minus 2z equals 0. Okay, so first of all, let position vector n1 be equal to what? The first plane. So that is going to be I plus j plus 2k. And the second one is going to be 2i plus 3j minus 2k. Okay, so first of all, we find the magnitude of this. So magnitude of position vector n1 will be equal to 1 squared plus 1 squared plus 2 squared, right? And that will be equal to 1 plus 1 is 2, 2 squared is 4. So it's going to be what? 6, right? And magnitude of the position vector n2 is equal to 2 squared plus 3 squared plus negative 2 squared. And that will be equal to 4 plus 9 plus 4. And that is what? 4 plus 4 is 8. 8 plus 9 is basically 17, right? So that is the magnitude of n1 and n2. Okay, so we see that this times this will be equal to square root of 6 times square root of what? 17. And that is equal to, okay, so that is that. Then we find the dot of n1 times n2. So that will be I plus j plus k dot 2i plus 3j minus 2k. And that will be equal to 2 times 2i. We have what? 1. Okay, so once we have that, we can say that cos theta is equal to n1 dot n2 all over magnitude of n1 dot magnitude of what? N2, right? So we have that theta should be equal to cos inverse of, this is 1 all over square root of 6 dot square root of 17. And this is basically equal to, this is basically equal to 84.315, which is approximately equal to 84.32 degrees. So that is the angle between these two planes. Okay, so if you want to find the angle between two planes, just transform the plane to a normal. So plane 1 will be the first normal and the plane 2 will be the second normal. Once you have these two normals, the rest is what? Computations. All right, so that is the process we go through to find the angle between two planes. Okay, let's move on to question number 12. Okay, so with question number 12, we have a plane, okay? AS plus BY plus CZ equals D. That contains the points P, Q, and R, okay? And we want to find position vector R cross position vector P, Q. So if you have a question of this nature, first of all, find the position vector PR and the position vector PQ. Once you are done, they use the cross product, right? So here we're going to find position vector PR, which is equal to R minus P, right? So we're going to have R, of which is here, -1, 0, -2, minus P, 1, 1, -1, right? So we're going to have -1 minus 1 becomes -2. 0 minus 0, 0 minus 1 becomes -1. Then -2 minus -1, right, becomes -1, right? So we have position vector PR, we have position vector PR. So we have to also get position vector PQ. So position vector PQ will be equal to Q minus P, right? So we're going to have Q, which is right here, 3, 2, 6, minus the P, which is 1, 1, 1, right? So we have 3 minus 1, which is 2. Then 2 minus 1, which is 1. Then minus 6 minus 1 becomes -5, right? So we have position vector PR and we have position vector PQ. So what we have to do is to find the cross product. So PR cross PQ, right? So we're going to have our matrix, right? So PR we had -2, -1, -1. And PQ we had 2, 1, -5, right? So this is what we have. So we have to compute the determinant. So we're going to have -1, 1, -1, -5, -j, -2, 2, -1, -5, plus k, of which we have -2, 2, -1, 1, right? So we're going to have I into -1 times -5 becomes 5, plus 1, right? Minus j into -5 times -2 becomes 10. 2 times -1 becomes -2. Then we know that negative is affecting at that side. So we're going to be plus 2 plus k into this times this becomes -2. This times this becomes -2 times -1. So it becomes plus 0, right? So plus 2, okay? Plus 2. So we're going to have this becomes 6i and this here becomes -12j plus 0k, right? So we're going to have, finally, we're going to have PR cross PQ will be equal to 6i minus 12j, right? So that is the position vector PR cross position vector PQ. So we are done with question number 12, right? Let's proceed with question number 13, right? Okay, so with question number 13, we are using the same preamble. Now we want to find the value of D in here, right? And you know that before we can get the value of D, we have to get the equation of the plane, right? So first of all, we know that from the beginning, we had position vector PR cross position vector PQ, which was 6i minus 12j plus 0k, right? So this was position vector PR cross position vector PQ. Okay, so this here represents our normal, right? Our normal vector. Okay, so this represents our normal vector. Okay, and we know that once you have the normal vector, the rest, what you have to do is you have to just choose any of the points. Then you can form your equation of the plane. Once you have the equation of the plane, the constant in there becomes your what? The value of what? D. Okay, so we have to do that. So this is our normal, right? Our normal vector. So we are going to pick any of the points in addition to this to find the equation of the plane, right? So we're going to pick P. So P will be our point, right? So P of 1, negative 1, right? That means that our x naught is 1, y naught is 1, and z naught is what? Negative 1. So we're going to write our equation. So x minus x naught plus b into y minus y naught plus c into z minus z naught, right? That should be equal to what? 0, right? So the 0 here is the constant. But once we are done, we'll have a constant value, and that represents what? The D. So let's go ahead and substitute the values. You know that this here is the A, this here is the B, and this is the C, right? So you're going to substitute that. Then we have 6 into x minus x naught is 1 plus B is minus 12, right? So we have minus 12 into y minus what? 1 plus C is 0. So we have 0 into z minus what? This one is what? Negative 1. So we're going to have what? Plus 1. And that should be equal to what? 0. Okay, so we have 6 into x minus 1 minus 12 into y minus 1 plus 0 equals what? 0. Okay, so when you expand this, you're going to have 6x minus 6 minus 12y plus 12 equals 0. So let's try to simplify this. So when you simplify this, you're going to have 6x minus 12y minus 6 plus 12 becomes plus 6, right? That should be equal to what? 0. So this can be written as 6x minus 12y plus 6 equals 0. And this is basically 6x minus 12y equals what? Minus 6. So the minus 6 here represents what? Our D. So this is the value of what? D. So hence the value of D is minus 6. The value of D is minus 6 as obtained here. Okay, so that is the end of question number 13. Okay, so with question number 14, we are using the same preamble. All right, we are to find the equation of the plane to this particular question. We are finding the equation of the plane. Don't forget that from question number 13, we obtained the equation of the plane before we were able to get what? The value of the D, right? And what we had was what? 6x minus 12y equals minus 6. This was the equation of the plane, right? And this expression can be expressed in a simpler way as divide here by 6, here by 6, here by 6, right? So we're going to have x minus 2y equals what? Minus 1. That's the equation of the plane is x minus 2y equals negative 1. So that's the equation of the plane is obtained as x minus 2y equals negative 1. Right. So that is basically the process. If you are given a plane, right, and this plane, right, the normal vector that you obtain For instance, you obtain 6i minus 12j plus, let's say, k, right? This here becomes your A, this becomes your B, and this becomes your C, right? So if you have those parameters, then the rest, if you want to get the point, once you have the correct vector or the correct normal vector, just choose any of the points and then you can get your equation of the plane. That is very simple, right? So now let's move on to question number 15. Okay, so with question number 15, we have position vector A, position vector B, and position vector C. All right. And we want to find the volume of the parallelepiped with edges A plus B, B plus C, and C plus A. All right. So first of all, we have to find A plus B, B plus C, and C plus A, right? So before we can get the volume of the parallelepiped, we have to first find A plus B, and that will be equal to 2i minus 3j plus 5k plus b, which is 3i minus 4j plus 5k, right? And this will be equal to 2 plus 3 becomes 5i, minus 3 minus 4 becomes minus 7j, 5 plus 5 becomes 10, right? So we have 10k, right? So this becomes our A plus B. We have to also find B plus C, B plus C, and that will be equal to 3i minus 4j plus 5k plus 5i minus 3j minus 2k, right? So this will be equal to this, and this becomes 8i, this and this becomes minus 7j, this and this becomes plus 3k, right? So this is also B plus C. Finally, C plus A will be equal to 5i minus 3j minus 2k plus A, 2i minus 3j plus 5k, right? So we can say that this and this will give us 7i, this and this will give us minus 6j, this and this will give us plus 3k. All right, so this also becomes our C plus A. So once we have A plus B, B plus C, and C plus A, we can go ahead and find the volume of the parallelepiped. Okay, so first of all, let's A plus B be equal to what? U, position vector U. And also let B plus C be equal to what? Position vector V. And let C plus A equals position vector W, right? So once we have those position vectors, what is next? We know that volume of a parallelepiped will be equal to, according to this question, it's going to be A plus B dot B plus C cross C plus A, right? So we have to first find B plus C cross C plus A, right? And we noted this as U, position vector U dot position vector V cross what? Position vector W, right? So we have to find that. So let me write our position vector U here, which is 5i minus 7j plus 10k, right? So we can say that V cross W will be equal to, right? So our V which is right here as 8 minus 7, 3. And our W, which is right here as 7i minus 6 and 3, right? So this, when we find the determinant, we are going to have I into minus 7 minus 6, 3, 3, minus j into 8, 7, 3, 3, plus k into 8, 7, minus 7, minus 6, right? So we're going to have, this will give us minus 21. This and this will give us minus 18. And you know that off diagonal there is a negative, so it's going to be what? Plus 18 minus j into this and this will give us 24. 7 times 3 will give us 21, so we have minus 21 plus k into this and this will give us minus 48, and this will give us plus 49, so we have plus 49, right? So basically we can say that this will break down to minus 21 plus 18 is going to give us minus 3, so we have minus 3i, and this will also give us plus 3, but there is a negative here, so it's going to be minus 3j, right? And also this part will give us minus 48 plus 49 will give us positive 1, right? So we have plus k. All right, so this is our b plus c cross c plus what? A. So we're going to dot this with this to have what? The volume of the parallelepiped. So we're going to dot that with the u. So we have u dot v cross what? W, right? So that will be equal to this, right? So we have 5i minus 7j plus 10k dot minus 3i minus 3j plus k, right? So when you break it down, we are going to have 5 times minus 3, it becomes minus 15, right? Minus 7 times minus 3 becomes plus 21, right? So we have plus 21. Plus 10 times 1 becomes plus 10, right? So we are going to have minus 10, minus 15 plus 21 plus 10, right? So basically we are going to have 16. So we are going to have 16, right? So 1, 6. Okay, so the volume of the parallelepiped is basically 16 cubic units, right? So the volume of the parallelepiped is 16 cubic units. 16 cubic units. So if you want to find volume of a parallelepiped given particular sites, right, what you have to know is that you have to first find, if you are given, for instance, what we have here, a plus b, b plus c, and c plus a, then you have to find all this before you can go ahead and do the rest of the computations, right? So you know that if it's just a plus b plus c, if it is just a, b, and c, then it's going to be a dot b cross what? C, right? So you just have to find b cross c, then you dot it with what? A. But in this instant, we were given a plus b, b plus c, and c plus a. So it means we have to find all this, then we cross this and this using the cross product, Once we are done, then we dot it. We use the dot product to find the 2, right? And that becomes the volume of the parallel pipe. All right, so that is the end of question number 15. Let's move on to question number 6. So with question number 16, we have two vectors A and B, right? Such that A plus B dot A minus B is equal to what? 8. And we also know that the magnitude of position vector A is equal to what? 8 times the position vector, the magnitude of the position vector B, right? And we want to find the position vector what? B, the magnitude of the position vector B. All right, so let's list these parameters down. A plus B dot A minus B is equal to 8, right? And we also know that position magnitude of the position vector A is equal to magnitude of the position vector B. All right, so first of all, we have to know that A plus B dot A minus B, we can use the dot product identity to evaluate this, right? So step one, use the dot product identity to evaluate this, right? So we know that A plus B dot A minus B can be equal to A dot A minus B dot B, right? You know that you'll be having minus A dot B plus A dot B. So this cancels off. When you expand it, this is what you have to cancel out, but this will remain, right? Okay, so once we have this, then we can say that this is equal to, you know that A dot A is the same as absolute A all squared minus absolute B all squared, right? So now that we have this, don't forget that we are told that A magnitude of position vector A minus magnitude of what? Position vector B is equal to what? 8 from the question, right? We are told from here. We use the dot product identity to expand and have this. And don't forget that this was equal to what? 8. So that is what we have here. Okay, so step two. Let's say that, don't forget that we also have magnitude of position vector A is equal to what? Magnitude of what? Position vector B. So once we have this, then why don't you say that, or why not say that, let magnitude of position vector B equal to what? X. So if that is true, then we can say that magnitude of position vector A will be equal to what? 8 times what? X. So if this is true, then we can say that magnitude of position vector A all squared will be equal to what? 8x all squared. And this is equal to what? 64 x squared, right? So let's name this equation 2, and this one is what? Equation 1, right? Don't forget that this is also x, so we can say that this will finally be what? The square of it will be what? X squared, right? So let's consider this to what? Equation 3. So we can substitute equation 2 and 3 into equation 1 to find the value of what? X. Okay, so let's do that here. So when we substitute magnitude of position vector A all squared to be what? 64x squared here. Then magnitude of position vector B all squared to be what? X squared in here. And that should be equal to what? 8. right? So when we do that, we're going to have what? 63x squared to be equal to what? 8, right? We are interested in the x, so we divide here by 63, divide here by 63. So we have x squared to be equal to what? 8 over what? 63, right? And when you simplify this, you're going to have x to be equal to what? Square root of 8 over 63. Okay, and this basically equals, this basically equals 2 square root of 14 over 21, right? Square root of 8 over 64 over 63 is basically 2 times square root of 14 over 21, right? So we can say that we can say that we can say that the magnitude of B, the magnitude of position vector B is equal to this. Don't forget that we presented this to be what? X. The magnitude of a position vector B to be what? X. So once we have this, that means that this is what? The magnitude of what? Position vector B, of which the question what? Asks. So that is basically equal to 2 times square root of 14 over what? 21. And this is equal to 2 times square root of 2 over 3 times square root of what? 7, right? So this is the same as this. This expression is the same as this. So this is the magnitude of position vector what? B. That is question number 16. All right, so look at the process. This expression we have here, this dot product we have here, we can use the dot product identity to expand this. And when you expand that, you have this. Then don't forget that this expression was equal to what? 8. Okay? So once you notice that, then the rest is what? Computations. Don't, you are interested in finding the magnitude of what? B. So why not saying that the magnitude of B, the magnitude of what? Position vector B should be equal to what? X. So if that is equal to X, then you can make what? Substitutions, right? For X. And you have X squared minus what? 64x squared minus x squared is what? 8. It's very simple. All right. So you obtain the value of x, and that represents what? The magnitude of what? Position vector B. All right. So let's move on to question number 17. Okay. So with question number 17, we are interested in what? The magnitude of what? Position vector A. Don't forget that this is the equation that we were given. 8 times the magnitude of what? Position vector B. And we have the magnitude of position vector B to be what? 2 times square root of 14 over 21, right? 2 times square root of 14 over 21. So if you want to get the magnitude of A, then we just have to multiply it what? By 8. So we're going to have 8 times what? 2 times square root of 14 over 21, right? So we're going to have 16 times square root of 14 over 21. And this becomes what? The magnitude of what? Position vector A. So go through the process carefully. Magnitude of position vector A is equal to what? 16 square root of what? 14 over 21. And that is the magnitude of what? Position vector A. Now we can move on to question number 18. Right, let's dive into it. Question number 18, we want to find the angle between A and C. If A is equal to this position vector, B is equal to this position vector, and C is equal to this position vector. Okay, so first of all, if you want to find the angle between two position vectors, first of all, you need the dot between these two position vectors, and then you also need the magnitude of these two position vectors. So first of all, we have to find A dot C, and that will be equal to I plus 3j plus 2k dot minus I plus 2j plus 3k, right? So that will be equal to 1 times -1 becomes -1 plus 3 times 2 becomes 6. 2 times 3 becomes 6, right? So we're going to have -1 plus 12 becomes 11, right? So A dot C is equal to what? 11, right? So we have that here. So once we have that, then we also have to find the magnitude of what? A and the magnitude of what? B, right? So the magnitude of A will be equal to square root of 1 squared plus 3 squared plus 2 squared, right? So basically we're going to have 1 plus 9 plus 4, right? So the magnitude of A will be 1 plus 9 is 10, 10 plus 4 is 14, right? So we're going to have square root of 14, and that is the magnitude of what? A. Now we also need the magnitude of what? C. So the magnitude of C will also be equal to -1 squared plus 2 squared plus 3 squared, right? So we're going to have 1 plus 4 plus 9. So we're going to have 14 again. So square root of 14. So that becomes the magnitude. And we know that to find the angle between two position vectors is basically equal to cos theta equals A dot C over what? The magnitude of A dot the magnitude of what? B, right? So this will basically be equal to what? Cos inverse of A dot C over the magnitude of what? A times the magnitude of what? C. So this basically yields A dot C was 11. A, the magnitude of A square root of 14 times the magnitude of C square root of 14 as well. So basically, we are going to have the angle between A and C to be equal to cos inverse of 11 over square root of 14 times square root of 14, and that is equal to 38.3218. So we're going to have 38.3218, right? So this degrees. So basically we can say that our theta is equal to 38. Our theta is equal to 38.32 degrees, right? So that's the angle between A and C is 38.32 degrees. And that is question number 18. Now let's move on to question number 19. Okay, so with question number 19, we are using the same parameters, right? And we want to find the the position vector AB cross position vector AC, right? So first of all, we have to find each of the position vectors, right? So position vector AB is equal to B minus what? A, right? So that will be equal to, or B is 2I minus J plus 4K minus A is I plus 3J plus 2K, right? So basically 2 minus 1 is going to be 1 minus J minus 3J becomes minus 4J, and 4K minus 2K becomes plus 2K, right? So this is the position vector what? AB. Okay, so we have to also find position vector AC. So position vector AC will be equal to C minus what? A. So that will be equal to minus I plus 2J plus 3K minus A. Okay, so with position vector AC, we are going to have this, and this will give us minus 2I. This and this will give us minus J. This and this will give us plus K, right? So we have plus K here, right? So position vector AC is this, and the position vector AB is also this. So if you need position vector AB cross position vector AC, then that will be equal to I, J, K, right? And AB is what? 1 minus 4 and 2, right? And AC is what? Minus 2, minus 1, and 1, right? So let's break it down and find the determinant. So we're going to have neg 4, neg 1, 2, 1, neg J into 1 minus 2, 2, 1, plus K into neg 1, neg 2, neg 4, neg 1, right? So we're going to have I into this, and this will give us minus 4 plus 2, right? Minus J into 1 plus 4, right? Plus K into this, and this will give us minus 1. This and this will give us minus 6, right? So we're going to have, no, this will give us 8, right? So it's going to be minus 8. Minus 1 minus 8, right? So we're going to have in here, we are going to have minus 4 plus 2 is going to be what? Minus 2I. And this here is going to be what? Plus 5. Then there is a minus here is going to be what? Minus 5J, right? And this will give us minus 9. Minus 9 times K becomes minus 9K, right? So this is the value for what? The position vector what? AB cross AC, right? So let me write it here boldly. So we say that position vector AB cross position vector AC is giving us minus 2I minus 5J minus 9K, right? So that is basically the process you go through to find solution to this kind of problem. All right, so let's move on to the last part of the question number 20. Wow. So with the last part of the problem, we are basically going to refer to question number 19, right? Don't forget that with question number 19, we have to find position vector AB cross position vector AC, right? And we had negative 2I, negative 5J, negative 9K, right? So this was our position vector for what? AB cross AC, right? And don't forget that if you have position vector A, position vector B, and position vector C, and you want to find the area of the triangle with the same vertices A, B, and C, what you have to do is to first find AB, position vector AB, then you cross it with what? Position vector AC. Once you have that, then you take the magnitude of that, right? You take the magnitude of that. Once you have the magnitude, half of the magnitude becomes what? The area of the triangle, right? So we just have to find the magnitude of this. Once we are done, find half of the result. Then that becomes the area of the triangle with these vertices, right? So the area of the triangle with vertices A, B, and C will be giving us, we know AB cross AC, so AB cross AC, we find the magnitude of that, and that will be equal to square root of -2 squared, right? -2 squared plus -5 squared plus -9 squared, right? So basically we're going to have, this will give us 4, this will give us 25, and this will give us 81, right? So basically we are going to have square root of this, and this will give us 29. 29 plus 81 is basically 110, right? Because when you send 1 here, it's going to be 30. 30 plus 80 is 110. So we have 110, right? So this is the magnitude, right? So we need area of these vertices. So we're going to take half of this result, right? So we're going to say that square root of 110, half of this. Okay, so half of the magnitude that we obtain will be the area of the triangle, right? So we had square root of 110, so half of it, so square root of 110 over 2, and that is what? 10.48 over 2, which is 5.24 squared unit. All right, so that is the area of the triangle with these vertices A, B, and C, right? So we've done a lot. We've tried from question number 1 to question number 20. It's a whole lot, right? So thank you very much for watching. I really appreciate your time. Please don't forget to subscribe, share with your mates, and I'm going to give you more updates. Until the next video, keep learning and stay inspired. Bye-bye.